This video is about intelligent systems, which is the subject of Technology Guide 4 located in the back of your book. The term intelligent systems describes the various commercial applications of artificial intelligence. An example is UJAM. This is software that uses algorithms to produce sophisticated harmonies, bass lines, drum tracks, horn parts, etc. Plasma is another example. It is used in the railroad industry to mimic the complex behavior of dispatchers. Vertical search engines are another form of intelligent systems. They are distinct from a general web search engine in that vertical search engines focus on a specific segment of online content. Vertical search engines are also called specialty or topical search engines. The vertical content area may be based on topicality, media type, or genre of content. Vertical searching is used by sites like Kayak and is a threat to Google. Artificial intelligence is intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans and animals. The Turing test proposes a scenario in which a human user and a computer both try to act natural, and a human interviewer has to identify which is the real human. AI has permanent memory and decisions can use many design rules that are traceable. However, a narrow domain and low creativity are characteristics of AI. Natural intelligence is that demonstrated by humans. It is difficult and expensive to duplicate and disseminate. In very narrow domains, AI can outperform NI. You have likely faced off against AI if you have played any modern video game. In many cases, you can even adjust the intelligence level of AI when playing against the computer. Section 4.2 is about expert systems, which are artificial intelligence systems that emulate the decision-making ability of a human expert. Expert systems are designed to solve complex problems by reasoning through bodies of knowledge, represented mainly as if-then rules rather than through conventional procedural code. There are 4 phases of expert systems development, which involve specialized tasks toward capturing expertise from the work environment. The first is knowledge acquisition. For example, you are a doctor at a successful practice in the U.S. You are contacted by WebMD.com to provide your expertise on your successful new cancer identification technique. This is considered knowledge acquisition because they are attempting to capture your expertise. Second, knowledge representation occurs when knowledge is organized as rules or frames and stored electronically in a knowledge base. Third, knowledge inferencing is where the computer is programmed so that it can make inferences based on the stored knowledge. Fourth is knowledge transfer. Let's say you are the HR manager at ABC Corporation. You are using an expert system to score candidates for a new sales manager job. The scores you receive are an example of knowledge transfer. In other words, the scores were held in someone's head in a very informal manner, and now it is represented in the machine in an exact and formal manner. So knowledge has transferred from the human to the machine. There are 4 basic components of an expert system. First is the knowledge base. This is a store of information or data that is available to reference. The underlying set of facts, assumptions, and rules which a computer system has available to solve a problem is its knowledge base. An expert system's knowledge base is composed of facts and rules that guide final suggestions or decisions. Second, an inference engine is a component of the expert system that applies logical rules to the knowledge base to deduce new information. Third is the user interface. This is an important part of any system. The user interface is the means by which the user and the computer system interact, in particular, the use of input devices and software. The fourth component is a blackboard. An expert system's blackboard is like a database, but it is a bit more complex. Like a database, the blackboard is used as a common source of facts, except the blackboard is iteratively updated by a diverse group of specialist knowledge sources. Each knowledge source updates the blackboard with a partial solution when its internal constraints match the blackboard state. In this way, the specialists work together to solve the problem. The blackboard model was originally designed as a way to handle complex, ill-defined problems, where the solution is a sum of its parts. Next, we talk about the applications, benefits, and limitations of expert systems. Because of their characteristics, expert systems are most widely applied in commercially successful intelligent systems. Expert systems can replace human experts by applying expertise in a specific domain. Table TG4.2 defines 10 different types of expert systems. I will explain 4 of them. A prediction expert system infers likely consequences of a given situation. These are used to predict the climate, stock market, and even ovulation. A diagnosis expert system has been found to be useful in aspects of total quality management, such as statistical process control, quality costing, goods receiving, corrective action procedures, supplier development, quality function deployment, and field failure analysis. A planning expert system develops plans to achieve goals. These have been used to plan manufacturing floor layouts, software designs, and building construction planning and scheduling. A repair expert system executes a plan to administer a prescribed remedy. Software has used repair expert system capabilities for over 3 decades. Think of any expert you know. How can an expert system be built to utilize that person's knowledge? Table TG4.3 lists 11 benefits of expert systems. These features draw from the uniqueness of expert systems. For example, expert systems can support training because they provide explanations of how suggestions or decisions were made. The explanation facility can serve as a teaching device for novices in the organization. This can be helpful in selecting store locations. A manager can learn about the process by reading the decision explanations of the expert system on how the alternative locations were ranked. Section 4.3 is about neural networks. Machine learning is the study of computer algorithms that improve automatically through experience. Machine learning systems often use neural networks to learn from data. A neural network is a system of programs and data structures that simulate the underlying functions of the biological brain. Neural networks usually involve a large number of processors operating in parallel and are best used for analyzing complex, incomplete data. Neural networks are trained by being fed large amounts of data and rules about data relationships. Neural networks are used to research diseases like Alzheimer's, Parkinson's, and epilepsy. Neural networks have many other important applications. For example, in security, they are used to prevent money laundering. They can also be used in character recognition to understand handwritten notes. Neural networks can be used in image compression. With the internet explosion and more sites using more images and taking up vast amounts of storage space on social networking sites, using neural networks is appealing for image compression. Neural networks have also been used in stock market prediction. Companies claim amazing returns from their neural network prediction methods. Neural networks have also been used to create electronic noses to identify toxic waste, in medicine to examine odors from the body to diagnose problems, and in the food industry to inspect and grade the quality of food. Neural networks have been used for decades in credit scoring. Section 4.4 is about fuzzy logic. Fuzzy logic is a branch of mathematics that deals with uncertainties by simulating the processes of human reasoning. Fuzzy logic is a form of many-valued logic in which the truth values of variables may be in any real number between 0 and 1, both inclusive. It is employed to handle the concept of partial truth, where the truth value may range between completely true and completely false. Popular applications of fuzzy logic include anti-lock braking and cruise control in automobiles. Internet search also uses fuzzy logic. Google uses fuzzy logic because it is best for handling gray decision-making problems where there is no perfect conclusion. Fuzzy logic is best for handling unstructured data and decisions. Section 4.5 is about genetic algorithms. A genetic algorithm is a meta-heuristic inspired by the process of natural selection that belongs to the larger class of evolutionary algorithms. It involves a horse race among alternative solutions to find out which one is best. In the diagram you see here, each dot is an investment portfolio option. The genetic algorithm will identify the best one based on the assumptions at hand. A genetic algorithm is an optimizing method, which means the system chooses the best alternative based on options available. Design processes often use genetic algorithms. For example, genetic algorithms can be used to select the most aerodynamic body design of an aircraft, or choose the optimum batting order for a baseball team among the alternatives. If you want to evaluate the best product to market to your customers every month, you would use the selection function characteristic of a genetic algorithm. If a genetic algorithm recommends spending more on marketing and calling customers directly to improve product sales, you would be using the crossover functional characteristic of a genetic algorithm. Genetic algorithms are most often utilized in the operations department, including applications in assortment planning, aggregate planning, lot sizing within materials requirement planning environments, line balancing, and facilities layout. There are 5 stages to developing a genetic algorithm. One important step is the selection of the optimal solution. The key to selection is to give preference to better and better outcomes. The mutation step randomly tries combinations and then evaluates the success or failure of each outcome. In this way, it validates its final conclusion. Section 4.6 is about intelligent agents. An intelligent agent is an autonomous entity which acts upon an environment using observation through sensors and subsequent actuators toward achieving goals. Intelligent agents may also learn or use knowledge to achieve their goals. An intelligent agent is a software program that assists users in performing repetitive computer-related tasks. Intelligent agents are also called bots and often use expert systems and fuzzy logic behind the scenes. Microsoft's Clippy or Clipit is perhaps the most popular example of an intelligent agent. Clippy assisted users by way of an interactive animated character, which interfaced with the Office help content. Siri and Clippy are examples of personal agents. A personal agent takes action on behalf of the user. An information agent searches for information and displays it to users. A shopping bot or buyer agent is an example of an information agent. An information agent may offer real-time news and full-text premier publications. A weather app on your phone is an example of an information agent. The Amazon recommendation system is a form of an information agent. Monitoring and surveillance or predictive agents constantly observe and report on some item of interest. These images depict FBI agents monitoring suspects as they move around a city. The software tool they are using is a monitoring and surveillance agent. A user agent is also called a personal agent. The autofill functionality on your web browser is a user agent. If you use Duo or some other type of authentication software, that is also a user agent. Predictive agents constantly observe and report on some item of interest and anticipate what the future situation will be. A primary example is models that predict future weather. If you use airfarewatchdog.com to wait for the cheapest possible plane ticket to Australia for your summer vacation, this is also an example of a predictive agent. This concludes our chapter on intelligent systems. Thank you.